good morning or good afternoon or good evening or good night or good, I don't know what time it is when this video is being played back. To everyone, in this video I want to talk about code again, which I didn't do for quite some time. So it is time to do that once again. In my latest plugin release, no, not actually the latest plugin release was Nel Orbit, but the latest plugin release that was pretty huge, which was Nel itself, the plugin had a lot of modulators, and this is the header file where I have all the modulators. The class modulator has a bunch of subclasses like the Perl and noise modulator, the audiorate modulator, the dropout modulator, and so on. And I want to talk about the envelope generator that is used in the audiorate modulator, because I had to solve a lot of bugs there lately, and now it seems like it's pretty stable. So, or what does, no, not pretty stable, like just 100% stable, or 100% is a little hard, more like no one has told me of a bug yet that is still part of this implementation. So I solved all the bugs that seemed to exist for now, and that's why I think that it's solid now, and that should mean that it's pretty solid, I guess. If you find any bugs about the audiorate modulator, then please tell me about it, but this is just the current state of the envelope generator, and I think it's good enough to make a video about that. So this video is all about MIDI handling. This operator function is being called by process block whenever the audiorate modulator is used by Nel, and it gets the arguments of the audio buffer, the MIDI buffer, the number of channels out, and the number of samples. Now obviously you want to have two buffers in this modulator to begin with. One of them is the buffer for your envelope, so that you can multiply it with something else later to get, some dynamics going. And the other one is the note value itself. And I'm basically synthesizing this whole stuff in this whole range of stuff from here to this. This is the scope of my MIDI handling, and therefore also the handling of the ADSR-Envelope. And it works like this. At the beginning, I'm just defining that the first channel of this buffer is for the notes. And later in my implementation, I will use the same channel for different things, but I can just use it for that for now. And then there is a current value, which is always defined by note value plus pitch bend value. Now the first state, which is the easiest of all, is the MIDI buffer is just empty. There are no MIDI events coming in or out. It might be that you are currently holding down some notes. It might also be that no notes are being held at all. So what you want to have here happening is that for all of the samples, you just go on with whatever you did last time. So obviously the note values are just current value forever, and the envelope is just whatever the envelope did last time, and then processing going on with it. And I'm multiplying it with the safety coefficient, which is just a number close to 1, so that it does not reach the end of the delay, because I had some crackly noises due to going up to 1 itself. And now that is solved. Now the other condition is that the MIDI buffer is actually not empty, and you have to find out which MIDI events to deal with. So you start by just getting the first event from the MIDI buffer, and then you get the MIDI buffer iterator reference from that, because you can work with that later, like getting the message and stuff. And you also get the timestamp, the sample position from this reference as an integer, which is very useful because that makes it comparable with the sample of the sample loop. So I'm looping through all the samples of the sample loop, and then I have a condition again. Is the timestamp still bigger than the sample? If yes, then obviously we still just want to go on with whatever we did last time. So this is basically the same stuff as this. I could make a function for that to make that more clear, but I did not. Now else would mean that timestamp and sample is actually already the same, but it's not that easy because multiple MIDI notes could be on the same sample. If you are a fan of Black MIDI music, you know what I mean. If you don't know Black MIDI music, type in Black MIDI in YouTube and have a laugh. Anyway, what I'm doing here is I'm just getting the note on state from my envelope so that I know what the envelope's note on value was last time. And then I just try to find out if it's still the same. So while we still have the same timestamp as the sample, so it, as you know, it directly starts with this condition, so it will definitely go here in here at least once. Come to think of it, I could make this a do while loop to have one less condition in it, because I know that I will go in here anyway once. But yeah, at least it works. So then I get the message from my reference, and then the message has some more information for me, like, is this a note on event? If yes, then I get the new note value, and I'm casting it to float because later I want to have the opportunity to smoothen those values and to add some other stuff to it, like octaves, semitones, fine tones from parameters, and you know, and pitch bend, of course. So yeah, the new current value is being calculated, and then I'm setting note on to true, and I have to let my envelope retrigger, which is edge case handling, because in FL Studio I noticed that sometimes when a note off value should have been sent and then another note on value, the MIDI events were actually mixed up a little bit. So you have to consider that when you are just on one sample and there are multiple MIDI events, then sometimes they are sort of mixed up in some doors. So you have to manually retrigger an envelope, and it does not, it's not enough to just give it a note on value at the end of this method, because there could be a note off value just in the next moment. Then else it is a note off value. Then we check if the note off value is the same value as the current note value, because you might have a situation where you have a note and another note overlapping, and now obviously this note on, so it would retrigger and it would update the note value. But what would happen here if you would not check for if it's the same note value? It would send a note off. So this note would cut and would not keep on playing. So you just check if the values actually match, and only then the note on value is being set to off. So note off. So else if pitch wheel information. Actually, no, not actually. Yeah, there can only be one event at a time in this loop. It's just a little bit confusing, because you know, a note on and a value a note on message can come at the same time as pitch wheel. They are separated from each other, but still in this loop they are separatable completely. Now I'm getting the pitch wheel value and I'm converting it to float, and so that I can multiply it with my coefficient and then subtract 1 from it. My coefficient, by the way, is 2 times divided by some cryptic number, and this cryptic number comes from just hovering over the pitch wheel, no, the get pitch wheel value function, which says that, as you can read, 0x3 FFF is the maximum pitch wheel value. So basically whatever number that is, half that number is the moment when the pitch wheel value is just normal and does not alter the sound, and everything below the half of that number will make it pitch down, everything else will make it pitch up. So when I'm writing 2 in here, then that means that I want to have pitch wheel range of 2 semitones, and if I were to write 1 in here, then I would have to write 0.5 down here instead of 1, because this is half of this. If I wanted to make this flexible, I would put a 1 here and would put a 0.5 here, but then scale up the whole thing also. I don't know, something like that. Then current value is being updated again. So now it's going on with the event handling stuff. Now we are going on with the event because now we want to care about the next event in our list of events. And now if the event has reached the end, then the timestamp is being set to just num samples, so that when we go back to the beginning of the loop later, the beginning of the sample loop, then we find out that timestamp will continuously be bigger than sample, and we will just go on with what we have until the end. But in most cases, when you play a lot of notes, then this is not true. So you have to update the reference to the latest reference and get the new timestamp. And then you can go on. So as you can see, the while loop includes all of that stuff, but only when all the events have been handled that are on the same sample, we can finally put a new value into our buffer with note values and put a new value into our buffer with the envelope, because otherwise we would let the envelope change its state multiple times per sample, which is of course not cool. Now, while this was already pretty much for someone who has not made an ADSR envelope yet, I guess, I will also go a little bit into how the envelope works itself, so that you don't see just the high level context, but also why it works internally. So I have an envgen class here, struct, and it's actually quite small. And it does not even have a sustain state, because I designed it in a way that it does not need a sustain state, even though it has sustain as a parameter. I'm making a default envelope generator by just setting the attack to 1, decay also, sustain and release, and that will essentially act like there is no envelope when you just let that run by itself. I have got the sample rate and the current envelope value. It also always knows about its state and about its node on state as well. And there is a smoothing object in here that I run over the envelope at the end of each process to just make it slightly smoother, because I felt like that sounded better. Now, in my prepare to play method, I'm getting the sample rate, and I'm basically having a bunch of smoothers here for attack, decay and release. Alright, I was just confused because I thought that I just put the smoothing on top of everything at the end. But actually, I just remembered that I used the smoothing to slow down the rate of change of the envelope, and that's why this is a switch case. So the same smoothing is used for all of these states, but depending on the current state, I'm using one of these parameters for the smoothing. Sorry for the confusion, but I first had it a little bit differently and then I changed it to this. So I was just a little bit confused, but it's alright. So what I usually use to trigger this envelope is this function, where you can give it a node on value. It will update its internal node on and then process the sample with this method down here that is protected. If you just want to keep on processing without updating the node on value, then there is also this little method. And retriggering does nothing but changing the state back to attack. Now, the most interesting bit about this whole class is the process sample function, which does a lot of stuff depending on the state and then returns the envelope. Now, which states do we have here? We have attack, which means if this is a node on value and the envelope is still smaller than something close to 1, I could actually put the safety coefficient here. It seems to be the same value anyway, but I did not have the safety coefficient yet before I wrote this class. Now anyway, the envelope still needs to go here, so we are smoothing in it towards 1 with the current smoothing settings. Else, if we already reached this point, which is definitely something that will happen at some point, because even though my smoothing class will not ever reach its destination, which is 1, it will definitely come close enough to reach this value, and that's why it works. So we are putting it to decay mode, and then we are smoothing it towards decay continuously. I mean, we are setting the smoothing value to the decay coefficient. And if this is not a node on but a node off, then we are setting it to release and choosing the release coefficient for the smoothing. Now we are at the next sample and we might now be in decay state. If we are still node on, still have a node on value, then we will just put the env value to the output of our smoother towards the sustain value instead of 1, what we had before. So it will always try to converge towards sustain. It will never actually reach sustain, but it doesn't matter because it comes close enough and it's smooth. And if we have a node of value, then we just do the same as we did with attack, setting the state to release and setting the smoother to release as well. And if we are in release, then if we are not having a node on value, we will just keep on going towards 0 with our smoothing. And else we will set the state back to attack and then also the smoother towards attack. So I think that this is a pretty neat solution to make an ADSR envelope, because you don't even have to describe the sustain state in a separate case, but can just do that with the decay itself, and that makes it kinda very elegant in my opinion. And it also is very performant because it doesn't do a lot, and yeah, it uses some if statements, but most of the hard work is carried out by the cases, so that's pretty cool. And I could imagine making it even better if I used a filtering method that actually converges to the point that I'm defining here, like 1, and then it would go to 1 instead of 0.99. But I don't think that's something that we really have to care about, because as long as it sounds good, it's good. And speaking about the sound, you could of course increase some of the smoothness by layering multiple filters on top of each other, just like you would do to increase the slope of a filter in general, if you know a little bit about filters and stuff. Of course, this is some sort of low pass filter if you did not know yet. And yeah, that is how the envelope generator works, and that is how I'm handling MIDI in my plugin.